Yes, I have shared the screen. Can you see the screen?
Yes, I can see.
Okay. Okay, so this is about oxides. The first question is, this question is about compounds of nitrogen. State which nitrogen dioxide is an acidic or basic oxide and give a reason for your answer. You have to state
Okay,
whether the nitrogen dioxide is an acidic or basic oxide.
acidic oxide,
What's the
and
reason?
because nitrogen is a non-metal and most oxides of non-metals are acidic.
Very good. Very good. It's an acidic oxide because it consists of a non-metal. Okay. Okay, this one is again, I guess copper is the element 29 in the periodic table. Copper oxide is formed when copper nitrate is heated. You have to state the class of oxide to which copper oxide belongs and state the meaning of the Roman numeral 2 in the name copper oxide. And yes, this one is not a part of our syllabus. Moving forward, you are given the names of the elements of period 2 and the periodic table are shown. You have to answer the following questions about these elements. Each element may be used once, more than once, or not at all. Identify the element which has an oxide found in clean, dry air.
Um, clean, oxide, clean carbon.
Very good. Which of the carbon's oxide is found in clean, dry air? Is it carbon monoxide or
What?
dioxide?
Nitrogen, like
Uh, you mentioned it's carbon, right?
yes,
So, which of the carbon oxide are you talking about? Is it carbon monoxide or dioxide?
carbon. It will be carbon dioxide.
Yes, very good. Because it is naturally occurring component of the clean dry air. What about nitrogen?
They are uh, they considered like
Nitrogen
pollutants.
also form oxides. Yes, very good. But the reason is that they are considered as the pollutant gases.
Yes.
So we cannot say that they are the components of the clean air. Okay, so next part is identify the element which forms a basic oxide with the formula X2O. Basic oxide. When an oxide is basic, does it consist of an metal or non-metal?
Which one?
Uh, when an oxide is basic, does it consist of a metal or a non-metal?
Basic is metal.
Yes. So, which of the elements will form a basic oxide with the formula
Yes.
X2O?
Very H2O.
Yeah. What's the valency of oxygen? What's the
Valency of
oxidation number? Like,
like
yes,
two.
yes, it's 2 minus, right?
Mm.
It's 2 minus. So, what should be the valency or the oxidation number of this metal? The overall charge is zero. There is no overall charge.
Mm.
So, one atom of this X element, it must have a charge of plus 1, so that when we have two atoms of of that metal, it gives you a charge of x raised to the power 2 plus, so that when we combine them both, it gives you x2o, so that the overall charge it can become 0. You look for such a
Mm.
metal that has the valency of plus 1. Plus 1.
Lithium.
Very good, excellent. It's lithium. It belongs to group 1. So its valency is positive one. So we know that oxygen, it has the oxidation number of 2 minus and the overall charge is 0. So we are looking for such an element where the oxidation number or the valency of one atom is positive one, so that when we have two atoms the overall charge can become 0. So it would be lithium oxide. Okay, moving forward, this is about yes, it's about preparation of salts. A list of substances is given. Answer the following questions about these substances. Each substance may be used once, more than once, or not at all. State which substance is a salt that contains a positive ion with a charge of +1.
Positive ion contains
Positive ion with a charge of plus. It's a salt. The first
yes,
information that is given is that it is a salt and it has a charge of. Sorry?
sodium chloride.
Yes, very good, excellent. It's sodium chloride. Because it's positive ion, it has a charge of +1, and the negative ion also has a charge of -1. Okay. This question is about metals and compounds of metals. Choose the metal chloride that is insoluble in water. Magnesium chloride, potassium chloride, silver chloride, or sodium chloride. Which of these is insoluble in water?
Okay, it is silver chloride.
Which one?
Silver chloride.
Very good. Yes. You need to remember that most of the chloride salts, they are actually soluble in water, but silver chloride, this is an well-known exception, and it's insoluble, and it forms a white precipitate um, when we react it uh, into the solution. So the second question is, this question is about iron. Rust is hydrated iron oxide. You have to define the term hydrated. What do we mean by the
A,
term
sub-
hydrated?
a substance contains water.
Yes. What else? Containing water means what? Um, if I have salt crystals and the water is on the crystals outside of it, will that salt be considered as hydrated salt?
Yes.
No. If I have
Is it salt?
salt crystals, yeah, if I have salt crystals and the water is outside, like it is placed on the crystal outside, but it is not chemically combined with its structure, then it won't be considered as hydrated.
Hydrated.
The term hydrated simply means such a substance that contains water, but that water needs to be chemically combined within its structure. That's why we call it as water of crystallization. Water is needed to be bonded chemically. So, it's such a substance where water is chemically combined within its. Okay. Copper sulfate can be used to test for the presence of water. Anhydrous copper sulfate, when we add water to it, it becomes hydrated copper sulfate. State the meaning of the term hydrated. We have already discussed it. Describe how hydrated sulfate is changed to anhydrous copper sulfate. Yes. When we add water to anhydrous copper sulfate, anhydrous means, what do we mean by anhydrous? That does
Like
not have.
not okay.
Yes. So when we add water into it, it
Okay.
converts into hydrated copper sulfate. So if I have hydrated copper sulfate, how can I convert it back to anhydrous copper sulfate?
By heating it.
Yes, very good. By simply heating it. Zinc chloride is soluble in water. Choose one other compound that is soluble in water. Calcium carbonate, lead chloride, silver chloride, or sodium nitrate. Which of these is soluble in water?
It is sodium nitrate.
It's sodium nitrate. Very good. Calcium carbonate is insoluble because we know that carbonates, they are generally insoluble. Lead chloride is also insoluble, and this is an exception to the chloride solubility rule because we know most of the chlorides, they are soluble, but lead chloride, this is one of the exceptions. And silver chloride, this is also an exception because mostly the chlorides are soluble. So nitrate is the one which is soluble in water. A list of substances is again shown. You have to give the name of the substance that is a salt which has a negative ion with a charge of 2 minus.
Mm,
Which of these are ions? Sorry, which of these are salts?
there are chloride, there is magnesium, ammonium nitrate.
It's ammonium nitrate. And what's
Mm,
the chemical formula for ammonium nitrate? It's NH4 NO3. Then we have uh, copper chloride. It's CuCl2. Then we have sodium chloride, which is NaCl.
okay,
Then we have
the
sodium
sulfate.
sulfate, and it's Na2SO4, right?
Yes.
And yes, that's all. So, which of these will have a negative ion with a charge of 2 minus?
Two minus.
Yes,
Sodium sulfate.
very good, very good. It will get decomposed into Na plus ions and SO4 2 minus ions. Which negative ion is present in ammonium nitrate?
Mm, again, NO3 negative.
Yes, it's NO3 negative.
Mm,
Okay, and which is present in copper chloride? Which negative ion is present
Cl
in
minus.
Cl minus? Very good. And same goes for sodium chloride as
Sodium
well.
chloride.
So all the other ones, they have a charge of -1. This is only -2. So it's sodium sulfate. Okay. Then we are given which of these salts is soluble in water: barium sulfate, calcium carbonate, ammonium sulfate, or iron hydroxide.
Insoluble in water. Ammonium sulfate.
It's ammonium sulfate, right?
Yes.
Very good. All the other ones, they are insoluble. Okay. The Haber process it is used to manufacture ammonia. I guess ammonia. Have you learned about ammonia, like the uses of ammonia or the manufacturing of ammonia? Hmm?
It's like, yes, I have, I
In
think,
this
but it
chapter.
was not in this chapter.
Yes, in this chapter, I guess this is not included in
Yes.
this chapter. Okay. So, anyhow, if we look at this one, the Haber process it is used to manufacture ammonia. Ammonia reacts with an acid to form ammonium sulfate. State the formula of the acid used. Ammonia reacts with an acid to form ammonium sulfate. Which acid is
Sulfuric acid.
being used? As sulfuric acid. What's the formula? You have to tell the formula.
The fourth.
Sorry?
Sulfuric acid.
Yes, you have to tell the formula. For,
H2SO, H2SO4.
yes, it's H2SO4. State one use of ammonium sulfate. H2.
Mm,
So 4. It is mainly used as a fertilizer for alkaline salts.
yes.
Used as a fertilizer. Calculate the percentage composition by mass of nitrogen in ammonium sulfate. How do we find the percentage composition?
Mm,
First, you have to calculate the molar mass. What would be its molar mass? What's the mass of one
Oh,
nitrogen atom? It's 14. But we
okay.
have two nitrogen atoms over here. What's like you have to tell the mass numbers. You know them. What's the mass number of nitrogen? Like the atomic mass.
What would do?
What's the atomic mass of nitrogen? It's nitrogen 714. This is the atomic number, and this one is the atomic mass or the mass number. So, to calculate the molar mass of this complete compound, you have to calculate the uh, total mass of all the atoms that are present inside it. So, we have two nitrogen atoms. One nitrogen atom, it has the mass of 14. So, two will have the mass of 28. Then we have 8 hydrogens, and one hydrogen has a mass of 1. So, 8 will have a mass of 8. Then we have sulfur. And what's the atomic mass for sulfur? It's 1632. So it's 32. And what's the atomic mass for oxygen?
Like two.
Sorry? Atomic
Atomic
mass.
mass. Oh,
2?
yes.
I guess you are not getting what we are discussing right now. What do we mean by atomic mass of an atom? If I write that I have, let's say, I have an atom of carbon and I say that its atomic number is 6. What do I mean by that? that its atomic number is 6. What is an atomic number of an atom?
It's like the total number of protons.
Very good. So what's the mass number? Mass number is the total number of protons plus neutrons.
Oh,
Do you remember?
mm,
Like, are you um, hearing this term for the first time? I don't think so. How is it possible that you don't know
same
what's the
thing.
mass number? Atomic mass or mass
Um,
number? The
Atomic mass.
relative
Okay.
atomic
Yes.
mass. Yes.
Yes.
Okay, so for nitrogen, if you know, like if you know the symbols for them, you may have seen the atomic numbers and the mass numbers. Like when we write carbon, two numbers are written. On the lower side, we write 6, and on the upper side, we write 12. So the number that we write on the lower side, it's called the atomic number, and the number that we write on the top is called the
No.
mass number.
So
Do you remember?
in the tests and exam they give us the periodic table.
You
We
will be
don't.
given the periodic table.
Yes, we don't memorize.
Okay, okay, sure. But this is what we mean by mass number. You should
Okay.
at
Yes.
least
Yes.
know
I
that
know.
what is a mass number. Okay, so for oxygen, it's 16 for one atom, and we have four of the oxygen atoms, so it would be 16 times 4, it's 64. So the total molar mass, the formula mass for this ammonium sulfate, it would be simply the sum of all of them. It would be 28 plus 8 plus 32 plus 64, and it would give you 132. Now we have got the total formula mass for this compound. We are asked to find the percentage composition by mass of nitrogen. How can we find the percentage composition by mass of nitrogen? If the total mass is 132, we simply want to see that how much is the nitrogen contributing in this 132. So what's the formula to find the percentage? If I say that you have got 60 numbers out of 80, how do we find the percentage? You simply multiply the obtained
Multiply that.
with 100 and then you divide by the total.
Yes.
So what's the mass of nitrogen in this compound? The total mass of nitrogen. It's 28, right?
14, 28.
Yes, because we have two atoms. So you have to
Oh,
consider for
yes.
both the atoms. Both of them they belong to nitrogen. So the total mass of the that element or the total mass of the nitrogen it's 28. So to find the percentage, you will simply divide 28 by 132, which is the total mass of the compound, and you simply
Multiply
multiply
100.
by 100. Very
Okay.
good. And it would give you 21.2%. This is how we find the percentage composition. I can
Okay.
write the general formula so that percentage composition is total mass of the element divided by the total molar mass of the compound. Multiply by 100. Okay. Copper is element 29, the periodic table. Hydrated copper sulfate, it's a colored compound. It exists as hydrated crystals, which Contain water molecules. State the term given to water molecules present in hydrated crystals. What do we call that water molecules that are present inside the crystals?
What like crystallization?
You have to give the name for water molecules.
Water of crystallization?
Yes, it's called water of crystallization. You have to state the color of hydrated copper sulfate.
Blue.
Very good. It's water of crystallization. And write the formula of the hydrated copper sulfate. What's the formula?
USO4.
Yes, it's copper sulfate. Dot.
Nitrogen. mm, 5H2O.
Very good. Consists of five water molecules. 5H2. Okay, then we are given propanoic acid. It reacts with the aqueous sodium carbonate to form a salt. Suggest the name of the salt formed and suggest the formula of the anion in this salt. First, you have to suggest the name of the salt. Yes, it's propanoic acid.
Sodium propionate.
Very good. Very good. It would be sodium propanoate. And suggest the formula of the anion in this salt.
It's like CH3, CH2,
CH3, CH2. Yes,
CO minus.
it's CH3, CH2, COO minus. Very good. And uh, what would be the cation in this salt?
Cation of sodium propionate.
Yes,
It would be like Na plus sodium.
yes, very good. Okay, then we are given some symbol equations and word equations are given, and you have to tell that which of these equations represents a precipitation reaction.
Which of these are the precipitation? Um,
Start with option A.
Yeah, is it A because the reactants are is the answer A?
Yes, what's the reason?
Because like the product iron 3 hydroxide is like insoluble solid.
Yes, very good. It's option A. Which type of reaction is happening in B?
B is let's say it is neutralization.
This is neutralization. Okay, very good. Okay, then we are given magnesium, calcium, and strontium are group 2 elements. Aqueous silver nitrate, it is added to aqueous magnesium chloride. A white precipitate forms. Write an ionic equation for this reaction. Include the state symbols as well. Aqueous silver nitrate, it is added to aqueous magnesium chloride. We have to write the ionic equation for this reaction.
Aqueous, silver chloride. It would be like silver chloride and chloride plus
Yeah,
chloride.
first tell me the
Okay.
what would be the reactants and what would be the products.
Like the reactant in like the silver and chloride.
Tell me the overall reactants, like what will be the formula for silver nitrate and magnesium chloride.
Okay. Reactants. Mhm. Would be
For silver nitrate, it's Ag for silver, and what do we write for nitrate?
for nitrate.
Ag represents silver, and how do we write show nitrate? What's the formula? It's NO3.
Okay.
Silver nitrate is AgNO3. And what about magnesium chloride?
Like MgScl.
MgCl.
Yeah, two.
Mg, yes, very good. It's Cl2. Okay, but when we place them in an aqueous solution, they exist as ions. So, what four ions will we get by the dissociation of these two compounds? It will give you Ag plus and NO3 minus ions, and it will give you
Two
Mg.
plus.
Very good. It would be Mg2
Cl minus.
plus and Cl minus. So, what would be the reaction that will take place? Which of these ions will react with each other and give us a product?
It would be like um, silver chloride.
Sorry?
Like silver and chlorine.
Very good. The silver ions, they will, Ag plus ions, they will react with the chloride ions and give us a insoluble solid, a
Like
precipitate. And what's the name of that precipitate?
silver chloride.
It would be silver chloride. Very good. And what would be the other product that we will get?
Like
You can
for
tell me
like
the
the night.
formula for it. Sorry?
Like the
Like the other product. Is this the
for
only
like the
product you're talking
magnesium.
about? Yes. Like we will be
Oh,
left with magnesium and nitrate group, right? These
yes.
ions. So they will obviously give you the second product as well. So the overall reaction is AgNO3 plus MgCl2, and we will get AgCl plus MgNO3. It's magnesium nitrate 2. So this is the like the overall chemical reaction. Which of these is actually the spectator ions?
Like the spectacle ion.
Yes. We are actually
Yes.
looking for a white precipitate. Spectator ions are those ions that remain dissolved in the water
Magnesium. Yes.
and they do not participate
Magnesium.
in the formation of the solid. Yes.
Magnesium and
Magnesium.
nitrate.
Very good. Mg2 plus and NO3 minus. These are the spectator ions. And what are the spectator ions?
Like magnesium. Like
What do we, in general, what do we mean by spectator ions?
like ion. The ions are remain like dissolved.
Yes, they do not take participation in the formation of the solid or precipitate. So, to whenever we are asked to write the ionic equation, because we were told that a white precipitate forms, and we were asked to write the ionic equation for this reaction. So whenever we are asked to write the ionic equation, we remove the spectator ions always and write the ionic equation for the rest of the ions and the product that we will get from those ions. So the ionic equation would be, it would be simply Ag plus plus Cl neg, and we will get AgCl. Now tell me the state symbols.
Ag will be aqueous,
Very good.
chlorine will be aqueous, and uh, silver chloride will be solid.
Very good. Okay. Moving forward. Okay, we are given sulfuric acid has many uses. Dilute sulfuric acid, it is used to make salts known as sulfates. A method consisting of three steps is used to make zinc sulfate from zinc carbonate. Add an excess of zinc carbonate to 20 centimeter cube of 0.4 mole per decimeter cube dilute sulfuric acid until the reaction is complete. Filter the mixture, heat the filtrate until a saturated solution forms, and then allow it to crystallize. Suggest two observations which show that the reaction is complete in step 1. Two observations that will show that the reaction is complete in step 1. In step 1, when you add the excess of zinc carbonate to dilute sulfuric acid until the reaction is complete, how will we know that the reaction is now complete?
Like fizzing will stop
Very good. The bubbling will stop. What's the reason?
because like the reaction produces like carbon dioxide gas.
Very good. Very good. What's the, like, if I ask you to tell me the chemical equation for it, what's the chemical equation?
What will be very interesting.
Yes. When, when you add zinc carbonate to dilute sulfuric acid, it's zinc carbonate, ZnCO3, and we add it to dilute sulfuric acid, which is H2SO4. What would be the products?
It will be like zinc sulfate, carbon
Very
dioxide, and water.
Yes, very good. It would be zinc sulfate plus carbon dioxide plus water. Okay. Okay, yes. So the first observation can be that the bubbling will stop because carbon dioxide is produced during the reaction, and once the bubble stops forming, it will indicate that all the acid has been reacted. So the first one is bubbling stops. What's the second one?
Second,
Yes,
like the zinc carbonate stops to dissolve, like stops
very good.
dissolving.
Very good. The solid zinc carbonate, it will start settling down at the bottom. So solid zinc carbonate stops dissolving and starts settling down. Okay. State why it is important to add an excess of zinc carbonate.
So like the sulfuric acid gets like reacted
So
completely.
that, yes, very good. So that all the acid can be utilized. Okay. Define the term saturated solution.
Like a solution that contains like maximum amount of solid that can be dissolved in like a solvent.
Yes, very good. Okay, then you have to name another zinc compound which can be used to make zinc sulfate from dilute sulfuric acid using this method.
Zinc compound can be zinc sulfate. Uh, can we use zinc zinc oxide?
Just a minute. We can simply say that contains maximum amount of dissolved solute at a specific temperature. Okay. So what's its name? Another zinc compound which can be used to make zinc sulfate from dilute sulfuric acid. Yes. What
Yes,
did you say?
zinc oxide.
Okay, it could be zinc oxide. Yes. What would we get if we react zinc oxide with sulfuric acid? Like if I react zinc oxide with sulfuric acid H2SO4, what would be the products?
Zinc sulfate.
It would be zinc sulfate and
Zinc will be zinc. It will be zinc sulfate.
yes,
There will be like zinc sulfate plus H2O plus CO2.
plus H2O plus CO2. Can you see any carbon in the reactants?
Uh,
Yes.
uh,
Zinc sulfate, zinc from this compound and SO4 from here, and we will be only left with H2O. So we will get zinc sulfate and water. There will be no
okay,
carbon dioxide
okay.
produced in this reaction when we use zinc oxide for the production of zinc sulfate. There will be no carbon dioxide. There will be only zinc sulfate and water. Okay, suggest why this method would not work to make barium sulfate from barium carbonate and dilute sulfuric acid.
Uh, because like
Yes,
it is insoluble.
yes, very good. Because barium sulfate is insoluble. So when barium carbonate starts reacting with the sulfuric acid, we can say that a layer of insoluble barium sulfate will form on the surface of the solid barium carbonate. So this crust, like that layer, it will uh, coat the remaining carbonate and it will prevent the acid from reaching it. So as a result, the reaction stops immediately and we cannot obtain a high yield of the product. That's the reason. Clear? Or it's of 1 mark, so you can simply say that barium sulfate is insoluble. Like, have you got the reason or not?
Yes, I'm
Okay.
having.
Okay. Okay, then we are given potassium is a group 1 element. Aqueous potassium hydroxide, it reacts with a dilute acid to produce potassium chloride, which is a salt. Name the dilute acid used.
And the dilute acid. It could be like potassium chloride
Uh, Potassium chloride. This is the
or
result.
producing potassium. Okay,
Potassium chloride, it is a salt.
so hydrochloric acid.
Very good. Because we are looking for such an acid that must contain the chloride ion so that we can get
Yes.
potassium chloride because it contains a chloride ion. So we are looking for that acid which contains a chloride ion. So the answer can be dilute hydrochloric acid. It's dilute HCl. State the type of the reaction that is taking place.
Crystallization.
Very good. It's neutralization. Okay. Name the experimental technique that is used when salts are made by reacting a dilute acid with an aqueous alkali. What's the name of the technique?
Just
We know that when both the reactants they
filtering.
are colorless, we use a technique that is used to like determine the exact point where they have like completely reacted without adding the excess acid. To know the exact point of neutralization, which technique do we use?
It is just tit-
Yes,
titration.
very good. It's titration. Okay, when aqueous silver nitrate it is added to the aqueous potassium chloride, a precipitate is formed. State the color of the precipitate that will be formed.
Stating the precipitate, the color of precipitate. White.
Very good. It's white. And name the precipitate that will be formed.
Silver, silver chloride.
It would be silver chloride. Very good. Now you have to write the ionic equation for the reaction and include the state symbols as well.
With
So,
potassium chloride. Right.
yes, you have to
Like
write the ionic
the,
equation for the
mhm.
production of silver chloride. We will again
uh,
ignore the spectator ions. You only have
uh,
to write those ions which will take part in the formation of the precipitate. So what
silver.
very good it would be Ag plus
mm, Cl minus.
very good Cl minus because we know that our precipitate is silver chloride, so obviously it would
uh,
consist of silver and chloride ions, and it will give you AgCl. Now tell me the state symbols.
it will be aqueous and silver aqueous, chlorine aqueous, and
Okay.
the product is solid.
Solid, very good. And what are the spectator ions in this reaction?
Uh, Potassium
It's potassium and
and nitrate.
very good. Okay, then we are given a student prepares the calcium nitrate by adding calcium carbonate to dilute nitric acid. Write the chemical equation for this reaction. Prepares calcium nitrate by adding calcium carbonate to dilute nitric acid.
Nitric chemical value.
So, what are the reactants?
It will be like it will be calcium carbonate and
Very good.
nitric
It's
acid,
calcium carbonate and
nitric acid.
very good. It's nitric acid and calcium carbonate. So, what's the chemical formulas for calcium carbonate and nitric acid?
CaCO3,
Very good. It's CaCO3 plus
HNO3,
it's HNO3 for nitric acid. And what would be the products that we will get? Yes, it's
CaNO3 2,
calcium nitrate
calcium nitrate plus carbon dioxide and water.
Very good. Plus carbon dioxide plus water. And is it balanced?
There should be two nitric acid.
Very good. Very good. And what about the state symbols?
For the calcium, like state symbols,
Yes, the state symbol.
calcium carbonate, solid,
Very good. Let's solid.
and nitric acid is aqueous,
Very good.
and then
We will get calcium nitrate.
calcium nitrate will be
Is it
uh,
is
solid.
it soluble or insoluble?
Calcium nitrate.
Yes.
Calcium nitrate is soluble.
Very good. It's soluble. So, which state symbol do we use to represent the soluble salts? Do we use aqueous or solids?
Use for 25.
Or soluble salts? This is a soluble salt, we know that. So, its state symbol would be aqueous. For soluble salts, we use aqueous, and for insoluble salts, we use solids.
Solid.
You already know each and everything. Just don't get confused during
Okay.
the exam. I know you know everything that I'm telling you already know it, but you just don't need to panic. Have confidence,
Okay.
and then uh, I know you will ace it, inshallah. Just don't get
Mhm.
confused. Okay, so what about the state symbols for carbon dioxide and water?
What will be liquid and carbon dioxide gas?
Very good. Describe the two observations during this reaction. One is obviously
Uh,
of carbon dioxide, so you will see
carbon
bubbling.
fission.
Yes, and
And
what about
then the calcium carbonate like dissolved.
very good? The solid, it will disappear.
Oh yes, solid.
You can write in your own words whatever you
Okay.
find suitable. So it dissolves. Okay, the uh, student, it continues to add calcium carbonate until it is in excess. The student then removes the excess calcium carbonate by filtration and collects the aqueous calcium nitrate. State the general term given to a solution collected from filtration.
So one continues to add calcium carbonate.
Yes. What do we
The
call that
current
solution?
term like
What do we call that solution that we get after the filtration?
filtrate.
Very good. It's filtrate. Okay. And the student gently heats the aqueous calcium nitrate until the solution is saturated. So, just what is meant by the term saturated solution, we have already discussed it. Describe how crystals are produced from a hot saturated solution.
Crystals are produced
From a hot
mm,
saturated solution.
like we like when the allow the solution to like cool.
Very good. Crystals are produced by simply cooling the hot saturated solution. By cooling. And this one is state the term used to describe, determine the value of X, number of moles, and again it's about moles and everything. The student heats the crystals to remove the molecules of water. And calcium nitrate crystals are hydrated and have the formula this one, where X is a whole number of molecules of water. State the term used to describe the calcium nitrate after the molecules of water have been removed.
Take like the term used to it. A molecule does not contain.
After the molecules of water have been removed, we only use two terms. One is the anhydrous and one is the hydrated. Hydrated is used
Uh,
when
uh,
water is added, and when the water is removed,
no, anhydrous.
very good. The term is anhydrous. Uh, Calculate the student heats a sample of the salt and forms 2.46 grams of calcium nitrate and zero point 0.6 moles of water. Determine the value of X. Use the following steps. You're already given the steps. You have to calculate the molar mass of calcium nitrate. For calcium, it's we have only one atom. It's 40.1. The molar mass is 40.1. For nitrogen, it's 14, but we have two, so it would give you 28. And for oxygen, it's 16. So 16 times 3, it would give you 48.
Okay. Okay.
And then yes, it's 48. And then we simply add them. No, it's like one, like we have total of 6 oxygens, not 3, because we have a 2 outside the brackets. So the total number of oxygen atoms, it would be 6, right or not?
Because yes,
It would become it would become 6. So you have to simply multiply 16 times 6, and the total answer you will get be 164.1 grams. The unit that we use to represent the molar mass is grams per mole. You have to determine the number of moles that of calcium nitrate that will be formed. So number of moles is, we already know the formula. It's quite simple. It's simply mass divided by the molar mass. So the mass it's given in the question, it's 2.46, and you simply divide it by the molar mass, which is 164.1 grams per mole. So the number of moles would be 0.0150 moles. How can we calculate the value of X? In the question, you are given that 0.060 moles of water were formed. So how can we find the value of X?
X was okay. Determine the
Yes.
X zero.
Okay, we will discuss it in the next class. I actually have the next class. The time is over, so
Okay.
we will discuss it in the start of the next class. We have a class at 9, right?
When?
At 9.
Today?
Your father texted me
Oh, okay. Then my
that
bad.
he won't take the class on Wednesday, so arrange the
Oh
class
yeah,
today.
Wednesday. Yes.
Okay, so
Okay.
yeah, we will have the class at 9.
Okay.
Okay, so see you at 9. Allah Hafiz.
Okay.